This is audio lecture 2 for chapters 6 and 7, reliability and validity, and criterion reference tests. In the first video, we talked a lot about reliability. Now we're going to talk more about validity. As a reminder, validity is the degree of truthfulness of a test score, or is the test measuring what it's supposed to measure? We have 5 evidences of validity. The first is evidence based on test content. The second is evidence based on relations to other variables. These can be broken down to test criterion relationships, concurrent or predictive variables, and convergent and discriminant evidence. We will be breaking these down individually in the coming slides. Our other evidences of validity include evidence based on internal structure, evidence based on response process, and evidence based on consequences of testing. So the first of the evidence of validity is evidence based on test content. Test content refers to themes, wording, and format of the items, tasks, or questions on a test. So we can look at the validity, see if those questions are actually written appropriately, where they're getting at the core of what we want to measure. We can analyze the relationship between a test's content and the construct it's intended to measure. A panel of experts is employed to judge the relevance of test content to its construct. So we can take those experts and judge the evidence or the relevance of the test to make sure that that test is actually capturing what we want it to measure. The second evidence of validity is evidence based on relations to other variables. We can analyze the relationship between test scores and variables external to the test. An external variable is a measure or test that assesses the same or different constructs that the test is supposed to measure. So we have 2 commonly used methods to measure our evidence based on other variables, and that's our test criterion relationship and convergent and discriminant evidence. We will talk more about those, but the biggest thing is that the external variable is a measure or test that assesses the same or different constructs that the test is supposed to measure. The test criterion relationship is the relationship demonstrated by comparing test scores with one or more external variables that are considered direct measures of the characteristics or behaviors in question. It's the evidence of the relationship of a test score to a relevant criterion. It's also known as a statistical validity and correlational validity. So the validity is based on determining the systematic relationship between the criterion and other measures used to estimate the criterion. In practice, the test criterion relationship is confirmed by establishing a statistical relationship between the test and the trait being measured. We also have 2 test criterion relationship evidences. We have concurrent evidence and predictive evidence. Concurrent evidence, the criterion is measured at about the same time as the alternative measure. So an example of that is to measure body fat via skin fold, and we could measure body fat via the bod pod at the same session. So we could use those 2 different concurrent examples of measuring body fat at the same time to try to get a more valid relationship. We also have predictive evidence, which is criterion that's measured in the future. So, or predictive evidence, success in graduate school is represented. We can look at criterion that is the GPA and graduate status, and we can look ahead based on how well you'll do at graduate school based on your GRE score or your undergrad GPA. So we're using data to predict future success. Development of the criterion measure is important in establishing test criterion validity evidence. Examples of how this can be obtained include actual participation, known valid criterion, expert judges, tournament participation, or a known valid test. We have convergent and discriminant evidence. We need to collect convergent and discriminant evidence in order to determine validity and reliability. Convergent evidence is a relationship between test scores and other measures intended to assess similar constructs. For example, if we want to measure physical activity on a questionnaire, we would expect our questionnaire to correlate well with other questionnaires measuring physical activity. We also have discriminant evidence. Discriminant evidence is a relationship between test scores and other measures intended to assess different constructs. Using that same example, we would expect our questionnaire for physical activity to have a low correlation to a questionnaire measuring a different construct. Let's say knowledge, IQ, right? So there are two different constructs, so we would expect them to be to have low correlation to each other. We also have a group difference method, which is where 2 to 3 groups are compared to verify the construct being measured. So we would give that questionnaire to multiple groups or give both questionnaires to multiple groups in order to compare and verify that the questionnaires are getting to what we want them to. For evidence based on internal structure, we're looking at the degree to which the relationship among test items and test components conform to the construct on which the proposed test score interpretations are based. For example, if a test is designed for a single ability or trait, the score of each item should highly correlate with the total score of the test. So if we use that physical activity questionnaire example again, each question on the questionnaire should highly correlate to the overall total score that one would get on the questionnaire. So if most of the questions, let's say it's on a 5-point scale, people are answering 5, but then on question number 6, most people are answering a 1, then maybe there's something wrong with how that question is worded, or maybe that question's not actually answering or assessing what we think it should be. So we need to look at each item to see that it's highly correlated with the overall score of the test. The correlation and factor analysis are often used to establish the internal structure of the construct. We also have evidence based on response processes, which is the degree to which the processes of test takers or scorers are consistent with the intended interpretation of scores. Evidence is collected by analyzing individual responses, such as systematic observation of a person's response behavior. So, for example, we can assess a student's problem-solving strategies by asking them to report their decision process using the Think Aloud protocols. The recorded decision process should match the construct being measured. So, for response processes, we're looking at the individual and how the individual is responding to all of the items on the test. And then we want to make sure that those scores are consistent with the intended interpretation of the scores. We also have evidence based on consequences of testing. This focuses on scoring meaning and the intended and unintended consequences of assessment use. Evidence can be collected by numerical qualitative and quantitative methods. Qualitative methods are usually data points that have open-ended questions. Things like observations and case studies aren't necessarily numerically heavy. We can make qualitative data have numerical correlations using things like Likert scales or having questionnaires have scales, but that's the difference. Quantitative methods are more what we think of as like traditional data or number outputs. These things can be group differences by t-tests or other statistical uses. One of our examples of consequences of testing is using the body composition of a special population incorrectly because we used an equation that was developed for another population to try to predict the composition of that special population. So for example, if our special population was individuals with Down syndrome, individuals with Down syndrome often have a higher body fat percentage and lower lean body mass than people without Down syndrome. So if we used a scale that was determined off of people without Down syndrome to try to predict body composition of people with Down syndrome, we'd have a lot of flawed data because that body fat percentage skews differently based on that population. So we can't just apply a scale or an equation for one population that was designed for one population to another population. We need to make sure we're using appropriate predictions and equations to get appropriate data outputs. We need to integrate validity evidence into our testing. However, we can't always do this at one time. One of the questions is, should we collect all the evidence when validating a test? And it's almost impossible to collect all the validity evidence at one time, and certain evidences may be more important than others. Instead of using that one-shot study design to collect validity evidence, long-term effort should be made to continuously collect multiple types of validity evidence. So remember, validity is looking at, is the test measuring what it's supposed to measure? This is a diagram of reliability and validity terms. This is figure 6.2 in your book, and this is just a really good reference to keep and refer back to when we're trying to talk about our measurement characteristics. This just gives us a nice visual flow chart of all of those terms and how they're related to each other. You don't have to memorize all of this, but it is something good to refer back to. For example, when we're looking at the reliability side, we need to know the difference between subjective measures and objective measures. And we do need to know inter-rater objectivity versus intra-rater objectivity. And then under the objective measures, we need to look at, we talked a lot about the interclass and the downline of that, and not so much about the intra-class. So you don't need to worry about that as much because we didn't really talk about ANOVAs. And then when we're talking about validity and the evidence based on, I would know that whole side of the chart and what all of those terms mean. That will be really helpful. This is figure 6.3 in your book, and it's the application of the PPM, which remember is the Pearson product moment, correlation, and reliability and validity. You might see something like this on your test. This is something I would know. So if we're looking at that correlation between X and Y, and then that application or interpretation. So in the first line, we have trial 1 for the X and trial 2 for our Y, and that gives us our reliability estimate. We have rater 1 versus rater 2, and that gives us our objectivity estimate. Form A versus Form B is our equivalency estimate. Our test versus our concurrent criterion gives our construct validity estimate. And our test versus our future criterion gives us our predictive validity estimate. So this chart, highly recommend that we understand it and memorize it. I realize I said to memorize that previous figure. Your exam will be open note, open book, so you don't necessarily need to memorize it, but you should understand how to utilize it. This is going to be the end of part 2. Please go ahead to part 3.